Yes. So just what we discussed in the previous session, Hadoop is meant for storage and processing. It's meant for storage HDFS and for processing. Currently, we are going with Spark. Hadoop is not for online applications. Hadoop is for batch applications. Hadoop is not for online. There are two types of applications, as I said. Online applications, user interactive applications. The user gives the input, booking a movie ticket, making an online payment. Batch applications, user non-interactive application. User is nowhere required. Railway ticketing, PNR status, and generating credit card statements for millions of customers. Yes. Drawbacks with the current databases, limited storage, no parallel processing. If volume increases, the speed decreases. So just I was giving you some examples, right? Select total amount from sales 1, total amount from sales 2, total amount from sales 3. From record to record, if the data is increasing, speed decreasing, right? Which query execute faster among the three? The first query executes faster among these three because and here complexity increases, speed decreases. Here total amount from sales 1, average amount from sales 1, standard deviation of amount from sales 1. Here average is a two-step process. So first sum to be calculated, next average to be calculated. It is a time-taking process. Yes. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. The biggest challenge today handling semi-structured and structured data. But databases can handle only structured. Hadoop follows clients. Hadoop doesn't follow client. Hadoop doesn't follow client server architecture. Hadoop follows master slave. Single master with multiple slaves. Single masters with multiple slaves, right? Yes. Hadoop cluster, group of nodes connected in a network. There are two types of nodes, I mean systems. Master node and slave nodes, one master and multiple slaves. Master node responsibility, assigning tasks to the slaves, load balancing, fault tolerance, task assignment, load balancing, fault tolerance, and health monitoring. Assigning the task to the slaves, the task should be equally balanced to all the slaves. Fault tolerance, slave node responsibilities, storing data, processing data. Yes. Hadoop advantages like unlimited data storage, horizontally unlimited scalability, very high speed processing because of parallel processing, can handle all varieties of data. So open source commodity hardware means no licensing required. It can run on any hardware, right? See, there have seen many tests conducted to see the speed of different databases. So Yahoo has taken a table of 100 TB consisting of 1024 columns, task sorting based on 16 columns, sorting based on 16 columns. Time taken by Oracle, it has taken around 3.5 days to process this. MySQL has taken nearly 6 days. Teradata has taken 4.5 hours. Netija. Netija has taken 3 hours. Hadoop has taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes. Spark is 100 times faster. Even though Hadoop has got very high speed as compared with this days and hours, but Spark is still 100 times faster than Hadoop. The Spark of speed is very high speed processing. Why databases like Oracle won't support unlimited storage? Databases max limit on the number of slaves. We talk about these databases like Oracle, MySQL, SQL Server, DB2. They can support up to 256 nodes. Further than that, it won't support. But Teradata, Netija, Vertica, they're supporting 512 nodes. But Teradata and Netija, they're supporting 1024 nodes currently. So none of these databases or specialized databases are handling unlimited data storage. But there is no limit on the number of slaves that Hadoop can have. Yahoo can go with yes. Yahoo, when first time implemented Hadoop went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Facebook, when first time implemented Hadoop went with 8,000 nodes. Currently, Facebook going with 52,000 nodes. Yes. Now, how exactly data storage and processing is happening within Hadoop? How exactly data storage? Data storage and processing within Hadoop. Data is stored in the form of files. In Hadoop, data is stored in the form of files. Files again subdivided into blocks. Files again subdivided into blocks. Default block size. The previous versions it is 64 MB. In latest versions default block size 64 MB. In latest versions it is 128 MB. In latest versions it is 128 MB. I got a file f1.txt. Size equal to 200 MB. You got some telecom data. Or some banking data. Assume default block size. Into how many blocks it is divided? I have taken a small number of blocks. Number of blocks equal to file size by default block size. File size by default block size. File size is 200, default block size is 64. Approximately equal to 4 blocks. B1, B2, B3, B4. B1 64 MB, B2 64 MB, B3 64 MB. This is 8 MB. In this 56 MB is free. In Hadoop, data is stored in the form of files. Files again subdivided into blocks. Default block size 64 MB. In latest version, it is 128 MB. f1.txt size is 200 MB. Banking data. Default block size 64 MB. Number of blocks, file size by default block size. Yes. f2.txt. Is my voice clear to all? Can anyone please confirm me once? Is my voice clear to all? Anyone please confirm me once? Hmm. f.txt size 192 MB. Yes, it has got telecom data. One 192 by 64, exactly 3 blocks. I'm storing it as B5, B6, B7, right? B5, B6, B7. Exactly 64, 64, 64 MB. The file is divided into 3 blocks. 64 MB, 64 MB, and 64 MB. If we talk in B4, 56 MB is free. Why this B5 data are not stored in B4? When 56 MB free in V4, why B5 data? When 56 MB free in V4 block, why B5 data is not stored in V4? Retrieving f1.txt. Assume if B5 data stored in B4, assume. (64 MB) less B2 also like 64 MB less B3 also like 64 MB plus B4 8 MB plus 56 MB. Two 56 MB. But actual file size is 200 MB. So when retrieving so when retrieving banking data, you got 56 MB of telecom data, which is a wrong computation. Which is a wrong computation. Design principles with respect to HDFS blocks. Design principles with respect to HDFS blocks. Every file should have dedicated number of blocks. Every file should have dedicated number of blocks. In a single block, no two files data to be stored. In a single block, no two files data. In a single block, no two files data to be stored. Every block will have equal value. Every block will have equal value. Every block will have equal volume except the last block. Every block will have equal volume except the last block. Let me check it here. And except the last block means here 64, 64, 64. The last one will have 8 MB. Design principles with respect to HDFS blocks. By default, it is 64 MB or 128 MB, but we can also increase or decrease the replication. We can also configure. We can also configure increase or decrease. Yes, we can also configure increase or decrease the block size. Configuring the block size. For that, we need to for that we need to go to the Hadoop install directory. That is Hadoop /etc/conf/hdfs. Further, we need to go to the Hadoop install directory. hdfs-site.xml. Open this hdfs-sort.xml file and configure the following. So configuration, dfs.block.size, like 50 MB you can give, 50 MB you can give, or 100 MB you can give, 150 MB you can give. So it's in the configuration property. Yes, configuration slash, okay. Which is advantageous? Which is advantageous? Having the which is advantageous? Having a, which is advantageous having a bigger or smaller default block size? If bigger block size. If bigger block size, if bigger block size. f1.txt, f1.txt. Say f1.txt is 1000 MB default block size. Default block size 500 MB. If you have taken default block size as 500 MB, how many blocks? Number of blocks equal to 1000 by 500. That equal to 2 blocks. So here Here in this case, right, B1, B2, B3, B4. B1 stored in system 1, B2 stored in system 2, B3 stored in system 3, B4 stored in system 4. Here also system 5, system 6, 16, 7. Two blocks, right? Here is it advantages or means here B1, B2, B1 and B2, B1 stored in system 1, B2 in system 2. B1 by system 2, B2 by system 2. Here only two systems are running. Here only two systems are running parallelly. If block size equal to 128 MB, if block size equal to 128 MB means means around 8 systems will run parallelly. If block size equal to 128 MB means around 8 systems will run parallelly. And we achieve more parallel processing. Case 2. If box size is smaller. If block size is smaller. Example. F2 and F2.txt. 100 MB. Default block size. 10 MB. Number of blocks 100 by 10. 10 blocks. 100 by 10. 10 blocks. Up to B10. Stored across 10 systems. Which one is advantageous? Try to respond. Having more block size or less block size? Which one is advantageous? Yes. Hmm. Here already it is a already it is a small file. Already it is a small file. And again divided into smaller blocks. Here already it is a small file and again divided into smaller blocks. Distributed across multiple slaves. Distributed across multiple slaves and are processed, and again the results are collected. It is the time taking process. So so it should not. So the block size should not be too big or too small. So the block size should not be too big or too small. So that's why. So that's why Hadoop is giving default block size as 128 MB. How exactly the data stored and processed? I'm going to discuss three cases here. Observe these three cases. If the number of blocks equal to number of slaves, for example, 4 blocks, 4 slaves, very high speed, number of blocks equal to number of more parallelism. For example, f1.txt, f1.txt, right? f1.txt, what is the size? Assume that the size is 230 MB. Default block size 64 MB. Assume default block size 64 MB. Number of blocks, how many? 230 by 64. 4 blocks. 4 blocks. B1, B2. Okay. How these 4 blocks? 4 blocks means here B1, B2, B3, B4. B1, B2, B3, B4. B1 by S1, B2 by S2, B3 by S3, B4 by S4. 4 blocks stored in 4 slaves. So here this is the master, these are the slaves. Master slave architecture, right? Single master and multiple slaves. Master slave, master slave. In B1, 10 lakh records. In B2, 10 lakh records. In B3, 10 lakh. In B4, 10 lakh records. Assume B1, B2, B3, B4. B1 in S1, in S2, in S3, in S4. B1 by S1, B2 by S2, B3 by S3, and B4 by S4. Here, this is what master node. Within the master node, name node. Name node stores metadata information, data about data. It won't store actual data. Data about data it is going to store. f1.txt, b1, b2, b3, b4. b1 stored in s1, b2 by s2, b3 by s3, b4 by s4. Means how exactly the data is stored. Now how the data is getting processed. Now check this. This data storage. Now data processing. Now we see data processing, right? Yes. Your job is to process f1.txt. Always job is divided into tasks, number of tasks, number of unique blocks, number of unique blocks. Here, how many unique blocks? How many unique blocks means 4 unique blocks. Means 4 tasks. Job to process f1.txt. T1 task, T2 task, T3 task, T4 task. For executing B1 10 lakh records. This for executing B2 10 lakh records. T3 for executing V3 10 lakh records. T4 for executing B4 10 lakh records. T1 for executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. 10 lakh, 10 lakh, 10 lakh records. So who should execute this T1? Task 1. Who should execute this T1 task? Who should this is T1 task executed by T2 by S2, T3 by S3, T4 by S4. Who should execute a T1 task? S1 only should execute, no other choice, because executing this B1 10 lakh records is nothing but the T1 task. It has to be executed by S1, T2 by S2 only, T3 by S3 only, T4 by S1 only. Here four tasks. Here four tasks. T1, T2, T3, T4. Here four tasks, T1, T2, T3, T4. Here four tasks are executed by four slaves. S1, S2, S3, S4. Parallelly. Four tasks are executed by four slaves parallelly. Four tasks are executed by four slaves parallelly. So that's why we see high speed. None of the tasks are in the waiting state. Four tasks executed by the four slaves parallel. No task is in the waiting state. This case one. Now observe this case two. Yes. Observe this case two. Okay, 1 second. Just a second. Case two, right? If the number of blocks, if the number of blocks greater than number of slaves, number of blocks greater than number of slaves. Number of blocks, how many? Four. Number of slaves, assume two. So number of blocks B1, B2, B3, B4. B4. Number of slaves, how many? S1, S2. F1.txt. F1.txt. Assume the size is f1.txt, assume the size is 230 MB. Default block size, assume default block size 64 MB. Number of blocks, B1, B2, B3, B4. But how this 4 blocks into only 2 slaves this time, only 2 slaves this time. This is S1, this is S2, B1 here, B2 here, B3 here, B4 here. 4 blocks, only 2 slaves. This week we have got a name node here. It stores metadata information. f1.txt into 4 blocks B1, B1 by S1, B2 by S2, B3 by S1, B4 by S2. 4 blocks into 2 systems. This is how exactly the data storage. Now we'll see the data processing, right? If more blocks, but less number of slaves. If you got a 10 blocks, right, but only 2 slaves. First 5 blocks in system 1, 5 blocks in system 2. Yes. Now see the data processing, right? The data processing. Your job to process f1.txt. Job always divides into tasks, number of tasks, number of unique blocks. This time 4 blocks, 4 tasks. Job to process f1.txt. For executing B1, T2 for executing B2, T3 for executing B3, T4 for executing B4. Who should execute the T1 task? Means B1 is present in S1 only can execute it. Now T2, who should execute this task to? As B2 is present in slave system 2, system 2 only should execute. T3, where this B3? B3 is present in S1, S1 only should execute. B4, by S2. B1 by S1, B2 by S2, B3 by S1, B4 by S2. There are 4 tasks. Here 4 tasks T1, T2, T3, T4 are executed by 2 slaves. Means here, if you observe carefully, S1, S2. S1 executing 2 tasks, S2 executing 2 tasks. S1 executing what? T1, T3. S2 executing 2, T2 and T4. When T1 is executing, T1 is executing, T3 will be in the waiting state. When T2 is executing, when T2 is executing, T4 will be in the waiting state. When T1 is executing, T3 will be in the waiting. When T2 is executing, T4 will be in the waiting state. Means only 2 tasks are executing parallelly, T1, T2. This T3 and T4 are in the waiting state. Means once T1, T2, their execution is completed, then only T3 and T4 will be executing. Means all the 4 tasks are not executed parallelly. So here you see lesser speed as compared to less parallelism. Okay, next. Case 3. Observe this case 3. More blocks, only one slave. More blocks means 4 blocks, only one slave. B1, B2, B3, B4. B1, B2, B3, B4, only one slave. slave. F1.txt 230 MB. Number of blocks 230 by 64. 4 blocks. B1, B2, B3, B4. 4 blocks, right? Single master and multiple slaves. Only one single slave right here. Yes. Only single slave. B1 here itself, B2 here, B3 here, B4 here. This name node maintains metadata, right? Name node. Here f1.txt. B1, B2, B3, B4. This is system 1. B1 in S1, B2 in S2, B3 in S3, B4 by, sorry, B1 in S1 only, B2 in S1 only, B3 in S1 only. Yes. B1 in S1, B2 by S1, B3 in S1, B4, all stored in S1 only. This is how exactly the data storage. Now, data processing. Job to process f1.txt. Job to process f1.txt. Job always divides into tasks, number of tasks. Number of tasks equal to number of unique blocks. Here, how many unique blocks? 4 blocks. 4 blocks means 4 tasks. T1, T2, T3, T4. Who should execute T1? S1 only. T2, S1 only. T3, S1 only. T4, S1 only. So here 4 tasks. T1, T2, T3, T4. Here 4 tasks T1, T2, T3, T4 are executed by here 4 tasks T1, T2, T3, T4 are executed by single slave S1 sequentially. Here 4 tasks are executed by by single slave S1 sequentially. So here sequential processing, one after the other, no parallel processing. In case 2, some of the tasks will be in the waiting state. In case 1, full parallelism, high speed, no task is in the waiting state if the number of blocks equal to number of slaves. Okay. So if more blocks, if more slaves, more speed. If less slaves, less speed. If only one slave, no parallel processing. Yes. So this is how exactly the data storage and data processing is going to happen. But if I go back to this case 1, here B1 10 lakh records, B2 10 lakh records, B3 10 lakh records, B4 10 lakh records, B1 10 lakh records. Here T1, T2, T3, T4. 4 tasks are executed by the 4 slaves parallelly. Suddenly, if any one slave goes down, If suddenly if any one slave goes down, you can see two drawbacks now. 10 lakh records are lost. 10 lakh records or 10 lakh records are lost, and T2 task also will be failed. If T2 task failed, the job failed. So how Hadoop will overcome this kind of thing, right? So 10 lakh records means if it is sensitive data, if they are sensitive data like banking data, huge loss. But if it is insensitive data, it's not a fine. But here T2 task also failed. T2 task means job also failed. How to overcome this means like in Hadoop, we have got the concept of replication and fault tolerance. We have got the concept of replication and fault tolerance, right? Yes. Replication, nothing but a duplication. And fault tolerance means when multiple tasks are executed by multiple slaves, suddenly if any one slave goes down, then the task of it will be assigned to any of the other slaves. This is called fault tolerance mechanism, right? So about this replication and fault tolerance, we'll discuss separately. Yes. Understood how exactly the data storage and data processing is happening? Right. So how that data is divided into blocks, how the blocks are distributed, right? Yes. Yes. And I need to discuss about the Hadoop architecture. Hadoop, I'll be discussing in brief. Hadoop storage architecture, Hadoop processing architecture, what are the various uh, storage components, what are the various processing components, and next later I'll be discussing about Hadoop beyond the latest architecture of Hadoop. What are the architectural changes we see in the previous Hadoop versions to this? And I said previously MapReduce was used a lot. Now MapReduce got outdated, so we are going with Spark component. As part of this course, I'll be discussing two processing components like Spark and Hive, one storage component, right? Like HDFS, one NoSQL, like HBase, and streaming component like Kafka. So two Spark and Hive are the two processing, one storage, one NoSQL, and the scoop is for import-export operation. Scoop is for import or export operations, not for processing. It is not for storage. For importing data from other sources to this, and also for exporting from the Hadoop to the other sources. For import and export operations, we go for Scoop. Hive is the mostly important component Hadoop, and Spark, I said, very high speed processing because of in-memory computation. And for unlimited data storage, we go for HDFS, and NoSQL. Hive and HBase will be integrating. Hive is a Hadoop, and HBase both we can integrate, so we can perform both the batch and online processing. Yes. So understood these things, right? How exactly the data storage and data processing, right? Yes. Next week, once again, right, you will get a new link. So try to get enrolled if anyone still, if you have not got enrolled. So you can see that the details in the chart, Zoom chart, right? Yes. The video, if you have missed that previous video and this payment details and that course content, everything, right? So next Saturday, we'll be continuing more discussion on this. More that replication, I'll be starting with a replication, duplication, and Hadoop architecture will be discussed before we go with the practical part. Next week, I'll be demonstrating about the software, the other things, right? You'll be added to the WhatsApp group. Next week, you'll be added to the WhatsApp group. all the things, right? So now I'm going to, so I'll stop for now. We'll continue next Saturday, more discussion on this, right?